Alright guys, so we're going to go ahead and get started with 2.6. Before we get going, as you know, we got the warm-up we're going to do, so make sure that we pause the video and work through the warm-up, and when you're ready to go, we'll play the video and see how you did. Alright, so in the warm-up what we're doing is just simply trying to see if we have true or false statements, and if it's false we need to give a counterexample. So we need to give a specific example either through a sentence using numbers or a specific set of numbers or by drawing a picture. So number one, we're just going to see again, are we dealing with a true statement or not? So as you look at number one, it says if two angles are complementary, then they are not congruent. So that's the thing what we're testing here. Are they not congruent in this situation? So if two angles are complementary, can we show an example when they are congruent? In this case we could show an example or a counterexample, so we're going to say it's false. The counterexample you should have had for this problem would be something like this. The measure of angle 1 is 45 degrees and the measure of angle 2 is 45 degrees. In this scenario, you've shown through a counterexample that if two angles are complementary, then they are not always going to be not congruent. They could possibly be congruent if they were both 45. Number two says if two angles are congruent to the same angle, then they are congruent to each other. You should, on this one, have gotten true. Now, we don't have to really show a counterexample on this. This is not a counterexample. I'm just kind of showing you how this example does work. This is actually one of our theorems from 2.6. This is literally the theorem. So I'm going to kind of state what it's saying here. So if we had angle 1, and they said it's congruent to angle 2. And again, the statement says if two angles are congruent to the same angle. So let's say angle 3 was also congruent to angle 2. So in this case, see how they both have angle 2? So we could substitute angle 3 in for angle 2 because it's equal to or congruent to angle 2, and I can make the following statement. I can say that angle 1 is congruent to angle 3. And in a way, we just proved that theorem. We didn't really write our reasoning out, but we proved it. We'll go back and prove it here in a little bit, but that is one of our theorems from, again, 2.6. Alright, number 3, supplementary angles are congruent. So in this case, you should have said false. And again, you have to give a counterexample. So in this case, again, we want supplementary angles are congruent. I want to show a scenario when supplementary angles are not congruent. So in this case, you can say the measure of angle 1 is like 100 degrees and the measure of angle 2 would be then 80 degrees. Because a situation like that, these angles are not congruent, but they are supplementary. They add up to 180. Okay, so there'd be your counterexample. There's a lot of counterexamples for that one. Alright, so make sure in your notes that we write down what it is or what goals that we are trying to learn today. So we'll write down the two statements. First goal, we are going to be writing a 2-column proof. So that's goal number 1. And goal number 2, we need to be able to go through proofs using deductive reasoning. So when you use deductive reasoning, you're just kind of you're going to analyze based off of clues or the information you're given, try to come up with a method or a way to work through a problem. So we're not really going to use what we did in 2.1 where we're trying to find a pattern necessarily. We're going to look at the clues around us and try to create a scenario that we could prove our statement with. Again, that'll be easier to explain as we do the actual proofs. Alright, so moving on, we'll kind of get started here. When we do our proofs, there's going to be 3 steps. Step 1 is we're going to have our hypothesis. So when we have any theorem or proof, and I'll put it off to the side here. If you have a theorem is basically going to be written in as an if-then statement, the A arrow B. So if A, then B. Remember, A is your hypothesis and B is your conclusion. So when you write proof, what we're going to have here is our hypothesis. This is going to be our given statement or statements, and this is going to the conclusion is going to be our proof statement. So that's what you'll see as you look at all the proofs. Now as we go through our proof, we're going to be using the following reasons. Those reasons are going to be definitions, postulates, properties, and theorems. The definitions, we have all those. That's why I wanted you to print all those out before we got into chapter 2. So you got all those definitions to use. You got your postulates. We've been writing them out as we go. We got our theorems. We've been writing those out as we go. Now the properties are things that you just know. We've used a few, but if you're multiplying, you would say multiplication. That's a property. That's a math property, or combining like terms, or substitution property. So just things that you've learned over the years that make sense. Like you can combine like terms and use that as your reason. If you know that you are using the distributed property, then you can state that. That's okay. Okay. But other than that, you're going to be using again definitions, postulates, and theorems. Okay, so that's going to be again the setup for all of our proofs. Okay, so we're going to go through our first example. Again, I'll take a second and make sure you write this down. If you need to pause the video, then do that. And then we're going to work through this first example. Alright, so example 1, it says write a justification for each step. So it's really, again, setting up a proof. So if I was going to do this using what we call a two-column proof, which is what I've been setting up with you guys, you're going to have two columns. And this first column is going to be your statements, which are given to you. And the right side will be your reasons. So what you need to be able to understand here is when you do a geometric proof, there's really no reason for you to get no points on any of these, because what you should always do when you're working out a proof is write down what's given to you. In this case, what's given is that B is the midpoint of AC. So that's your first step. Write it, because you're given that. You need to start somewhere. You're going to start with your given statement, and you're going to write the reason is given. So again, in these situations, you should really never get a 0 on any of these problems, because at the very least you can write the given statement. Okay, so what you're going to do is you're going to use some deductive reasoning. Say, okay, well I just wrote that B is the midpoint of AC. So based off of that, what do you know about midpoint? Well, if I know that B is my midpoint, then I know that those two segments must be congruent. Okay, so if those two segments, and I even got ahead of myself because we had another given statement, didn't we? So given that B is a midpoint of AC and AB is congruent to EF, you'll notice that is down here. That's a given. But going back to what I was saying, if you've said that B is a midpoint of AC, we know that we have two congruent segments, which are AB and BC. So that's what's stated right after this statement. Again, you have to use deductive reasoning and say, okay, they just said that B is a midpoint. What can I do with that? Well, I know the definition of midpoint states that if B is the midpoint of a segment, or if I have a midpoint of a segment, then it breaks the segment into two congruent parts. Okay, so at that point I can write down that AB and BC are congruent, and my reason would be definition of midpoint. Now, before I really go any farther here, I want to kind of talk briefly about a little extra sheet that I want you guys to write up as we go through your proofs. And this extra sheet, we would call it the Chapter 2 Proof Statements. What you're going to notice as you work through your proofs, especially starting now, is that certain definitions and certain properties and things like that are going to get used a lot. And right now, like, you have every single definition in the entire book in your binder. While that's useful, sometimes having too much information can be a hindrance, which means it can make things actually harder than it should be. So what you can do, and what I recommend that you do, is in each chapter we're going to write down all the statements that you end up using for your proofs, because you'll recognize or notice that you're going to use a lot of those concepts or those properties, theorems, postulates, or whatnot over and over again. So in this case, we just wrote down definition of midpoint for our second step. So you'll probably end up using that again. Not probably, you will. So let's write that down on this sheet. So as you do a few problems, and I'll put a check mark every time I use it so I can keep track of how often it's used, instead of looking through all your definitions in your entire glossary, once you've used it once, write it down, and then the first thing you should do as you're working through a proof is look at this proof statement sheet, because you'll recognize again that most of your concepts are going to come from that proof statement sheet, because they'll get used over and over again. So if we do that for every chapter, it's really going to simplify things a lot when you're trying to figure out which property should I be using. Look at that sheet first, and there's a good chance once you've done a few proofs that one of those statements listed on that sheet will be used in your proof. So right now we have definition and midpoint, and again I'll keep adding to that as we go through other proofs. But again, at this point I'm going to add another property here, but we have these two statements, steps 2 and 3, and you'll notice they have A, B in common. So what I'm going to do is I'm going to take BC. It really looks ugly. I'll try to clean it up for you real quick. Maybe change the color, it'll probably help. So I'm going to get rid of AB because they're both equal to AB, and I'm going to take BC, and here's the key word, I'm going to substitute it in for AB in my second congruent statement. So what that means is I'm going to write, and I'll keep it, we'll put that in black again, I'm going to write now BC is congruent, oops, I already have it written. I need to write my reason, I'm sorry. I'm going to write the BC, let's see, I'm substituting it, is congruent to EF. And there's really two reasons that you could use here, and you could see both, so I want to make sure you're prepared for them. One is going to be substitution. You'll notice that those are substitutions mostly used when you're doing, when you're plugging into an equation. This one isn't technically an equation. What they could be using though in this case is the transitive property, because it's congruence. So you write that out, transitive property of congruence. If you don't know what that means, again, this is basically what we have. AB, actually I'll write it this way so it's written the way it is usually in the book. You have BC is congruent to AB, and AB is congruent to EF. Then you can cut out the middleman and basically just say that BC is congruent to EF. Now the way this is set up, it's not really set up for transitive as much. Normally if you had the AB written second, it'd look more like what I have over here. But again, you'll see both of these used. It's the same basic premise. I mean, you flip it around, it's the same thing. So you can say substitution here, that's fine, because that's really what you're doing. But it's also, in a way, it's related to your transitive property of congruence as well. I want to make sure you're aware of both. So I would write both of these down. So substitution, check, and then transitive. You don't have to write the whole thing if you know what it is. If you don't know what it is, I'd write transitive property of congruence. So I don't want you writing transitive on accident. So we can check that off. And again, once you've done a few proofs, you'll realize again that these properties are going to just start repeating themselves just about every time. Okay. We don't need to write these statements down here. I'm just going over a couple key concepts. If you do want to write them down, then again, you can pause the video and do that. But we're going to be proving, going over some theorems now, and when we're going through a theorem, again, just understand what a theorem is. It's a statement that you can actually prove. It's not always going to be something that's super obvious. For example, when we do Pythagorean theorem, it's not like somebody just assumed one day that a squared plus b squared equals c squared. It's like, yeah, that looks right. You know, it's like, I got a triangle, I'll just call it, you know, I'll just say that a squared plus b squared equals c squared because I feel like it. It doesn't work that way. It was proven. It's a theorem, which means it has a proof associated with it. And so any theorem that you have can be proven, and we will prove as many of them as we can. I mean, it gets to a point where we don't have time to prove every single one, but we're going to prove a vast majority of them and understand they all have proofs. We are going to do some of those proofs today, here in just a second actually. So again, a theorem, it can be proven. Also, as you go through your proofs, you can use it as a reason in later proofs. So once you've proven something, if you have a list of theorems, you got theorem A, and later on you're trying to do like theorem, you know, P or something, you can use A to prove P. However, you cannot use theorem P to prove theorem A. You can't jump to you can't be looking at a theorem in chapter 1 or chapter 2 and go pull a theorem from chapter 12 to prove it. It has to build on itself, just like anything in math. You need to build properties up one by one. So theorem P is using concepts that if you just jump to theorem P, it'd be using concepts you haven't learned yet. So you can't, you know, use that to prove earlier proofs. So anyway, just understand that concept, you'll be okay. That's why I have you write down theorems as we go through the course of the year, and we don't have all of them printed out yet because you can't use most of them yet. Same thing with your postulates. Alright, so we have a couple theorems here. These are going to end up going in your theorem sheets. There's actually 4 of them in 2.6. Again, if you have time and they want, you want to pause and do them now, go ahead and do that. However, you can write them later, but just know what these are. So I'll just talk about them real quick, and then we'll move on. So the first one is the linear pair theorem. In a way, this actually can be written as a take that off. Okay, this can be written as a postulate as well. So what I'm wanting you to do is write down the linear pair theorem on your theorem sheet, and I also at least want you to again at the very least copy linear pair postulate onto your postulate sheet. They can and will be written both ways. It's a postulate because it's a given truth, and again, it's the hypothesis conclusion here. If A and B form a linear pair, then it makes sense that A and B are supplementary. And so that's what would make it a postulate. It's a given truth. It's something that you really don't have to see a proof to understand. But you can prove it, so you can call it a theorem if you like, if your goal is to actually prove it out. So for instance, if you were saying the linear pair postulate, and to you it's a given truth, and then someone didn't believe you, you would say, okay, well then let's state it as a theorem and prove it. So that's why it's terminology. It can go both ways. I've usually called it the linear pair postulate. The book calls it a theorem because mostly because they're wanting to prove it. So they write it as a theorem. But again, it is a given truth. The other one that we have is the congruent supplements theorem. We are going to prove this on the next slide. So again, I'm quickly just going to say what it states. So again, this is what that warm-up was saying. If angle 1 and 2 are supplementary, and angle 2 and 3 are supplementary, then I can state that angle 1 and angle 3 are congruent. We went over this in the warm-up, so we're going to go over it again. Alright, so we're going to do a 2-column proof on this one. We've done one before, so I'm going to kind of skip past this slide and get straight into our proof. So I'm going to give you a few minutes to go ahead and write this down. Again, it takes a couple minutes to do that, but again, what we need to do, first state that we are proving the congruent supplements theorem. So you're going to write proof of the congruent supplements theorem, because if you don't state that, then this should be a 2-step proof, because step 1 would be your given statement, and step 2 would be your proof statement by the congruent supplements theorem. That'd be pretty easy, but we're proving that theorem, therefore you can't use that theorem to prove it. Okay, it's just like, trying to define a word by using that word. It doesn't work that way. Okay, you have to define it by using other words. to explain it. So that's what we're going to do here. We're going to prove the congruent supplements theorem without using the congruent supplements theorem. Okay, so now hopefully you got that written down. If not, make sure this is paused so you have a moment to do that. And we're really just going to fill in the blanks. So I'm going to come over here and start with A. We'll write it off to the side because I don't really have a ton of room here. But A is always, that first statement is always the easiest one because it's the given statement. So all you would do to get started is write that angle 1 and angle 2 are supplementary. And then you would also say angle 2 and angle 3 are supplementary. So the thought process here, again, it's given to you right now, but when you get the worksheets here in a little bit, you'll realize that these statements are eventually going to go away. You're going to have to come up with these statements yourself. So what you'd have to do is look at the fact that they just said that those angles are supplementary. Well, you have to say, well, what can I do with that statement? And there's really only one thing you can do, and you know that supplementary angles add up to 180. So it makes sense that your second statement, you would take the angles and add them up and set them equal to 180, mostly because there's nothing else for you to do. There's really nothing else you can do at that point. You have to write that, or else you're not going to do anything, or it's going to be wrong, right? So you have to use that concept of supplementary in your second step. And that's what they did. Again, it's already up there for you, but if you had to do that yourself, you really had no choice. And again, step 3, you really have no choice. There's only one thing you can really do here, and you can see that angle 1 and angle 2, well, those equal 180. Well, angle 2 and angle 3, well, those equal 180. So this is one of those things that you should put on your concept sheet. Remember, you have your little chapter 2 reason sheet. I would put another one for substitution. We already did it earlier. We're going to do substitution a lot. Make sure you write that down. So substitution, in this case, you would write it out as the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Alright, so that's B, substitution. I substitute it for 180 because they're both equal to 180. Step 4, I don't normally do this because it's almost like a given, it's not needed, but if you do have a statement where you're saying an angle is equal to itself, that's your reflexive property. This is of equality. Now if they were talking about the angles themselves and they were doing congruent, this would be reflexive property of congruence. That is not what we have here, so I'll get rid of that. But they're really setting you up for this next step. They're saying measure of angle 1 equals measure of angle 3. Well, what they're doing is your final statement needs to be that angle 1 and angle 3 are congruent. So I need that angle 2 to go away. Well, there's only one way I can really do that, and that's to subtract the measure of angle 2 from both sides. So C, in order for me to get measure of angle 1 equals measure of angle 3, I had to subtract. So I'm going to do subtraction property of equality for C. And then finally D is just your proof statement. That's always going to be your final step. So that's angle 1 is congruent to angle 3. And that is a proof. And that's a proof of the congruent supplements theorem. Again, if it's a theorem, you can prove it. Or else it shouldn't be a theorem. Alright, so some of the, these next couple slides are really just quick tips for you. So again, before you start writing proof, these are things that I've been doing already. I'm just giving it to you in writing. So before you start writing a proof, you should plan out your logic. So you should kind of look at it and say, well, what can I do with this? Well, like the last proof we did, said, well, they're saying something about the angles being supplementary, so I should probably say that they're 180. And if they're 180, both of them are, I can probably substitute, and then if I can simplify that down, I can get angle 1 being the measure of angle 1 equal the measure of angle 3. Now I can say they're congruent. Like, you can kind of work your way through it. And you can even kind of make a sketch off to the side and kind of write your steps down and then figure out the reasons later when you do your proof, but plan it out. Okay, and if you're ever stuck, just look at the statement you're on, and if it's talking about midpoint, you probably need to look at properties of midpoints. Or if they're talking about two angles, see, can I add those angles up? Do I know what they equal? Are there any definitions that they say they're complementary? Again, you need to know your properties. If you don't really know your geometry properties, you will have a hard time. And that's why we need to write them down and keep track of the ones that we use a lot, so that if we are having a hard time with the properties, once we've gone through one of those problems, we can easily find that definition or property or whatnot again. Alright, again, just for your note here, there are 2 more theorems in this section, so make sure you're writing these down so you have them. Okay, so these are the last 2 from 2.6. And again, all they're saying here, we've got our right angle congruence theorem. So all right angles are congruent. So if A and B are right angles, then you can state that they're congruent. Again, if they tell you the angles are right angles, you know, and you're trying to, your proof statement is to state that angles are congruent to each other, you're going to need to be able to use this theorem to get it from this statement to this congruent statement. So that's how we're going to be able to do that. Anytime we're dealing with right angles, it's actually going to be a theorem. And the last one, the congruent complements theorem. Okay, if angle 1 and 2 are complementary, and angle 2 and 3 are complementary, then we can say that angle 1 and angle 3 are congruent. It's very similar to the congruent supplements theorem, obviously. Okay, it would be the same proof, you just be adding them up to 90 and not 180 like we did on the last one. Alright, so that's your last 2 theorems for this section. Alright, final little hint before we get into our worksheet. So if a diagram for a proof is not provided, again, draw your own and mark the information on it. Okay, so again, long story short, if there's a picture, draw it. If there's no picture, draw a picture. I mean, use that picture. That's why it's there. It's there for you to use as a visual aid, and as you're working through a proof, to label it to help you figure out the next step. Okay. Alright, at this time, what you're going to need to do is get it in your, if you're in class here watching this, you need to get in your groups, and there's going to be 1 sheet per group, 1 worksheet, proof worksheet. Because there's only 1 per group, you are allowed to get out your phones and take pictures of this worksheet so that you don't have to keep sharing the worksheet among the 4 of you. So I'll give you a minute to do that. Again, get the worksheet out. Again, if you have a phone, you want to take a picture of it so that you don't need to keep looking at the sheet and borrowing it from your group mates, and do that. And once you've done that, again, we can unpause the video, and I'm going to go over 1 and 2 with you. And then it's going to be up to you guys to finish the rest on your own as a group. So I'll give you a minute to do that, and then we'll get started. Alright, so hopefully we're ready to go, and again, before we really get going, make sure that you actually write down. You're going to be doing these obviously on a separate sheet of paper. It's going to take a moment to actually write down these statements. There's a lot to write. Once we write it down, we're just going to fill in the blanks. Okay, so make sure you've gotten this written down before we begin. That includes the given statement, the proof statement, the picture, and again, all your statements and the blanks for your reasons. Okay. Alright, so getting started here, again, the easiest step to have as you're going through a proof is to write down the given statement. Here, K is between J and L. Step 1, K is between J and L. Why? Because it was given to us. So write down given. Next up, they said JK was 6 and KL was 10. Notice that's step 2. That was given to us. So those are some easy steps. Now, you need to look at what properties we could possibly be using, and as we use those properties or those definitions, those postulates, those theorems, and we write them down in our chapter 2 statement sheet. And this one is going to be a new one, but again, if you look at the statement here, it looks like I'm adding segments, and you got to think to yourself, well, when did we add segments? What property or theorem or postulate told us we can do that? And you got to remember, if I'm adding segments, like JL is my whole thing, well, it's equal to this guy plus this guy. You add two parts up, it gets the whole. This was our segment addition postulate. So step 3 would be your segment addition postulate, and I would add that to your list of the properties that you're using for your proofs, because it won't be the last time you use that. Okay, so now that we know that the segment addition postulate, we got our equation. It looks like JK became 6. Looks like we substituted that. KL looks like we substituted 10. So this is going to be yet again substitution. Again, we're going to use that one a lot. So step 4, substitution. Step 5, it looks like we just added 6 and 10 together. So this is just good old addition. Nothing fancy. We added 6 plus 10, got 16. And you're done. You got your proof statement. Remember, your last statement has to be what it is you're trying to prove. I was trying to prove that JL equals 16. We've done that, so we're done. That's how you know you're finished with a proof. Alright, next up we have given that B is the midpoint of AC and BD is congruent to AB, which is our first two statements. Let me just go ahead and write that. Given. And again, we got a picture to go along with this, so we can picture what's what's going on here. So when they said that BD was congruent to AB, I can label that. BD, tick mark, is congruent to AB, tick mark. And I also know that B is the midpoint of AC. So if B is the midpoint of AC, I know those two segments right there are congruent. So I can see right there that's all congruent. We just have to prove it. So you start by using this concept right here. B is the midpoint of AC. Well, if I know B is the midpoint of AC, we've done this one already, then I know that AB and BC must be congruent. Why? Because of definition of midpoint. Again, if we're using a property for the second time, you want to put a check mark, another check mark next to it. You don't have to write the property again on your property sheet or your reason sheet for chapter 2. And just kind of remind you, hey, we've used midpoint before, definition. I'll use it again. Just keep track of it each time. Okay, and then once you have that, let's look at these two statements back here. BD is congruent to AB. AB is congruent to BC. Let's trim the middleman. Remember, we did a problem just really almost exactly like this earlier. And this one, I can, oops, I did the same mistake earlier. What we're going to have here is we're going to have now BD, our first statement, is congruent to BC, our last statement. This is another one of those transitive property of congruence reasons. So again, hopefully we're kind of coming full circle here as we went through this example. You really start to see these proofs have a lot of the same reasons and a lot of the same thought processes, because I went through a proof earlier, I almost did the exact same thing. For example, this is the proof we did earlier, and notice it's really the same problem. It's a different picture and whatnot, but it's really the same problem. We had B as the midpoint, we used definition, then from there we use the transitive property to make our final proof statement. So these you start to notice that as you go through enough of these proofs, you'll start to see that they do kind of repeat themselves in terms of the thought process required and the properties that are required. So that's why we keep track of the properties and the reasons for each chapter, because they tend to, even though they're not all exactly the same, they're all related. They're all using the same basic concepts. So keep track of them so that you know which ones you tend to use the most, and it makes it easier to find them as you go through proofs later on. Alright, at this point, what you need to do is work through the rest of this worksheet. Again, if you're able to check the answers, then do so, but only do so after you've attempted the problem. Do not go up and check answers only to copy them down. Do it once you've finished the problem, and make sure, again, if you decide to go up every problem, that's fine, but if you go through the entire worksheet and you're done, then still go up and check. I'd rather you make sure you're doing them right, not just doing them. It's important to get them correct. So go ahead and get started on that, and good luck.